We will wrap up chapter 1 today with this lesson, section 10. Notice we skipped section 9 in chapter 1. We're going to wrap up chapter 1, and our next time together will be a review work to get ready for a chapter 1 test. We introduced chordate geometry the last time we were together. We're going to continue on that vein. I'm assuming that most of you think this is pretty easy. I hope so. And this time will be no different than last time. I'm going to go through this rather quickly because I think for most of us, it is fairly easy. All right, so let's talk about slope of a line. For years, I was a high school teacher, which gave me summers off, and I did some construction work on the side. And I soon was encountering all kinds of phrases that carpenters used, and I was not familiar with them. One of them was the pitch of the house roof. If you are building a standard little ranch-style home, a house such as that has a roof that has a 410 pitch, and carpenters would talk about the pitch of the roof. 410, a 410 pitch rises 4 feet for every 10 feet of run. In other words, if you have a house, this distance is 10 feet, the house is going to go up 4 feet. Now, the interesting thing about carpenters, they called it a 410 pitch, whether you were going up this way or whether you were going down that way. In mathematics, we do it a little bit differently. The 410 pitch is fine, and that is correct. We would call the rise of 4 feet over the run of 10, 4 over 10, or you could reduce it to 2 over 5. That is the slope of this side. But when mathematicians do rise over run for a line like this, you go down 4 and then over 10. Down 4 would be a -4. The run is still in the positive direction. To the right is positive, to the left is negative, up is positive, down is negative. Okay? So we take it one step further. Carpenters are correct. 410 is a 4 over 10 slope. But when you're coming down the other side, it would be down 4 and over 10, or a -4/10 or a -2/5. Okay? I've got some pictures here of lines. I noticed that some of my lines did not get very dark, but the red and blues, I think you can see. For instance, starting over here, you can find the slope of this red line by going up 3, 1, 2, 3, and then counting over 1, 2, 3, 4. So I'm going up 3 and over 4. Rise is 3, run is 4, slope is 3 over 4. For the red line. Now I've got a couple other lines here, and maybe you're going to have trouble seeing these. But in a situation like this, you have a slanted line, okay? And a slanted line, you would want to try to find a slope, but let's talk about, just because it's so hard to see, this line goes down, your rise is going to be negative, and then you go in a positive direction. Now, as close as I can see it here, it looks to me like we're down 2 and over 1, 2, 3, 4, 5, 6, 7, 8. So if you're down 2 and over 8, down 2, -2, and over 8, or you could reduce it to a -1/4. This vertical line is rather interesting because you have no run at all. Like, for instance, I say you could go from here to here. We're going to go up 3, but you don't have a run. So up 3 is on the top, 3 over 0. 3 over 0 is, you can't divide by 0. This is undefined. There is no slope for a vertical line. Okay? How about a horizontal line, like the x-axis? Horizontal line, we could say I'm going to go from here to here, count 3 as the run, but there's no rise. It's strictly horizontal. So if you have no run and you have no rise, pardon me, you have no rise and a 3 run, in this particular case, no rise and a 3 run, that's a slope of 0. So horizontal lines have a slope of 0. Lines that go up have a positive slope. Lines that go down have a negative slope. And vertical lines have no slope whatsoever. How about the red and the blue over here? Okay. Now you can count blocks again. For instance, I can count blocks here and go 1, 2, 3, 4. I'm going to go up 4 and then over 1, 2, 3, 4. This is up 4 and over 4 slope. If you're going to go up 4 and over 4, that's a slope of 1. But there's another way you can do it if you don't want to count blocks. Rise, when you're going up and down, is the change in the y values. That's a Greek letter delta, which means change in. The rise is the change in the y's. The run, horizontal, is the change in the x's. So what you can do, if you don't want to count blocks, take your 2 points. I've got this point down here is -1, -2. This point up here is 3, 2. Okay? So I can subtract my y's to get the change in the y value. So I'm going to take -2 minus 2. The run, subtract the x values, -1 minus 3 is still -4. -1 minus 3 is still -4. And you still get a slope of +1 for the blue line. And you can do the red exactly the same way. Subtract your y values, subtract your x values, okay? And you can figure out the slope on that one. So let's, by the way, that should be a -3, +2. Sorry about that, put the wrong point. All right, so let's do it correctly. This is a -3 and up 2. This one is a +1 and down 2. All right, so I have, if I do my y values, 2 minus -2, and my x is -3 minus 1, I get 4 over -4, or the slope of the red line is -1. Okay? Slope, delta y over delta x, or rise over run. Let's talk about equations of lines. Equations of lines. There are basically 3 kinds of lines. You can have a vertical line. We've already found that vertical lines have no slope. Okay? The equation is x equals some number. Here's an example. Once again, this might be tricky for some of you to see this line. Here's a vertical line. It hits at x equal to 6. Okay? Every point on this line has an x value of 6. Every point. Millions and millions of points. You always go over 6, over 6, over 6, and then you either go up or down. So the equation of a vertical line is just simply x equals a number, and it has no slope. A horizontal line, on the other hand, let's do the x-axis because it's easy to see. Horizontal line, on the other hand, we just talked about has a slope of 0. And you should agree with me, if you are on this line, you can go all kinds of to the right and the left, but you never go up and down. The y value is always 0, okay? Any horizontal line, like this one down here, is always down 3. It's always down 3. I don't care what your x value is, you're always down 3. So a horizontal line has a slope of 0, and the equation is y equals some number. Now, I call them slanted lines. Slanted lines are simply y equals mx plus b, where m is the slope and b is the y-intercept. Slanted lines are incredibly easy if you have a picture. Like, for instance, look at the red line. The red line, y equals mx plus b. What is the slope? Up, 1, 2, 3, over 1, 2, 3, 4. Slope is 3/4. Y equals 3/4 x. Where does it hit the y-axis? -5. Incredibly easy if you have a picture. Let's look over here at the red line. The red line over there is a slanted line. We know it's y equals mx plus b. It looks like it's up 1, 2, and then over 1, 2, 3, 4. So if I'm up 2 and over 4, the slope of that line is 2/4 or a half, okay? Up 2 and over 4. Where does it hit the y-axis? It hits at 1, plus 1, okay? How about the green line? The green line looks to me like it's up 2 and over 1. Up 2 and over 1. Now, somebody might say, you always know which point to pick. I would have picked different points. Well, you could start up here and go down 2 and back 1. Down 2 is a -2. Back 1 is a -1. 2 negatives still make a +2. So I have y equals 2x. And where does it hit the y-axis? 1, just like the red one, plus 1. Finally, let's do this blue line. See if we can figure out the slope. Once again, it looks like it's up 1 and over 2, the same as the red one, and you can see they're parallel lines. They have the same slope. Up 1 and over 2, which is the same as this one, 1/2. But this one hits, the blue one hits at -1. Okay? So the blue one would be 2/4 or a half x minus 1. Okay? Equations of lines, vertical, go over this one more time. There's no slope. Equation is x equals a number, 0 slope on a horizontal. And the equation is y equals some number, a slanted line, y equals mx plus b. The m is the slope, and the b is where it hits the y-axis. Now, perpendicular lines have slopes that are negative reciprocals of each other. Remember reciprocals when you flip it? All right, so for instance, look at the green and the bluish colored line over here. Let's talk about this, okay? If I'm looking at this, let's find the slopes of each. How about the green one? The green one, I'm going to go down to get over to this point. I'm going to go down 1, 2, 3, 4, 5, 6. I'm going to go down 6, and then I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8. So I went down 6, and I went over 8, reduces to a -3/4. So the slope of that green line is -3/4. Now, what about this blue line? Let's see if we can find points here. Looks like it hits down here at -2. So I'm going to go up 1, 2, 3, 4, and I'm going to go over 1, 2, 3. Say it again. I'm going to go up 4 over 3. Up 4 over 3. Will you look at that? Perpendicular lines have slopes that are negative reciprocals of each other. You flip it and take the opposite to get there, or you flip it and take the opposite to get back to that one. Find the equation of a line perpendicular to this line and going through that point. Okay? Let's find the equation of a line perpendicular to this line and going through that point. Okay. If it's perpendicular to this line, it'll have a slope that's a negative reciprocal of this line. So let's start with 2x minus y equals 5. Let's find the slope of that line. Well, how are you going to find the slope? Put it in y equals mx plus b form. So I want to solve for y. I'm going to add the y over to this side. I'm going to subtract the 5 back. Would you agree with me? Right there is the slope. This line has a slope of 2. Okay? A line that's perpendicular to this line would have the negative reciprocal slope, would be a -1/2 x plus b. A -1/2 negative reciprocal because the lines are perpendicular. Now, we have to find where it hits the y-axis. Okay, you could either graph it, or I think it might be easier if we use this point. It goes through that point 6, -2. If a point is on the line I'm trying to find, it'll make that equation true. So I'm going to put 6 in for x, and I'm going to put -2 in for y. So -2, -1/2 of 6 is -3, add 3, b is 1. Equation, y equals 1/2 x plus 1. Okay? Let's do another equation of a line. I am thinking of a line. It goes through the point 2 comma negative 1, and let's say it goes through 3 comma 1. All right, I'm thinking of a line. It goes through those 2 points. Now, you can get a piece of graph paper. You can plot those points. You can count the blocks to get the slope. You can see where it goes through the y-axis, the y-intercept, and you can do y equals mx plus b. Or you can do y equals mx plus b without graphing. I'm going to try that method. So I need the slope. Slope is delta y over delta x. Subtract the y values, -1 minus 1, 2 minus 3. Okay? -1 minus 1 is -2. 2 minus 3 is -1. I get a slope of 2. So I know my equation is y equals 2x plus b. I put the 2 in for the slope. Where does it hit the y-axis? We're going to do the same thing we did back in this problem. Okay? We know it goes through those points. Those points have to make that true. So you can pick whatever point you want. How about I pick the positive one? 3 in for the x, 1 in for the y, 2 times 3 plus b. 2 times 3 is 6. b would be -5 when I subtract 6 over. So I now have the y-intercept, I have the slope. The equation of my line has to be y equals 2x plus -5. Okay? Homework on these problems. Oh, before we do that, yes. I thought I skipped a screen. If y equals 2x plus 1, then for each increase of x of 1 unit, y would increase by 2. Your slope here, y, is equal to 2 over 1x plus 1. Slope is rise over run. As x goes up by 1, the y values go up by 2. Okay? Like, for instance, if you wanted to graph this, and I don't have graph paper, but I think we can do it, it's going to hit the y-axis at 1. The slope is up 2 and over 1, or down 2 and back 1. There's the line we're looking at. Okay? As x goes from 0 to 1, it increases by 1. The y value increases from here up to there, from here to here. It goes up by 2. Okay? As x increases from here to here, the y value goes from here up 2. All right? So slope is a rate of change for the y value with respect to the x value. Now, you should be able to answer a business type problem for me. A small business produces widgets at a cost of y for every x widgets produced. If each widget costs $5 and the startup cost was $3,000, write the cost equation for this business. Okay, so the cost of y widgets is equal to $5 for every x produced. 5 times x plus, what did it cost to start the business? $3,000. Okay? Now, you should be able to talk about slope and y-intercept here. 5 over 1. Okay? For each x produced, for every individual x produced, the y value goes up by 5. The cost goes up by 5, so each widget costs 5. Plus 3,000. The 3,000 is the y-intercept. The y-intercept is where it hits the y-axis when there's no widgets at all being produced, 0. That's a startup cost, what it costs to start the business, okay? So you should be able to answer a business type equation on those. Now we'll talk about the homework. I've got a couple of one extra problem there, a chemical problem, because you know there's going to be a word problem or two on the test, and a variety of other problems dealing with